All right, we are going to talk about magnetic interactions with this activity. And our standard for this is going to be a third grade standard in the context of motion and stability with forces and interactions. And the exact standard is going to be 3PS2-3. It is ask questions to determine cause and effect relationships of electric and magnetic interactions between two objects not in contact with each other. So basically, this activity is going to show that our objects don't need to come in contact with each other before they start interacting because of the magnetic force. And this is the whole standard from NGSS. Don't really need to show that to students. So our student lesson objectives are going to be that students will understand the cause and effect relationship of magnetic force, and magnetic forces between a pair of objects does not require that the objects be in contact with each other. So basically this activity is going to give students an opportunity to play around with magnets, different types of magnets that attract to each other, and also metal objects. So you can see the attraction between the magnet and those metal objects that are attracted to the magnet. And they basically just get to fiddle around with them and play with them and kind of see and feel the exact attraction. And so I will show what I am going to do for the activity.
This is our activity with magnets. We are going to be using some metal objects to show the interactions between the metal objects and our magnets. So I have paper clips and some screws. Put the screws over here. We have a couple metal lids and a key with a key ring. Now the key itself is not going to attach to the magnets. It's going to be the ring that actually attaches. And then these are going to be our magnets that we're going to use today. It's this ball that is a magnet. And then we have these little tiny magnets, and I have 6 of them here actually, but you can see how small they are. But we're going to use all 6 of them together to show the different effects of them. And I'm going to start with the little ones. So I'm going to show you first that you don't have to come in contact with the objects for them to be attracted to the magnet. Like both of the screws came to that one because they're a little close together. Get the keyring. The keyring, if you notice, it kind of jiggled before I even got near it, and that is just it trying to, it's the interaction of the magnet with the metal ring. They're interacting without even touching. And then if you get close enough, they actually come together. And kind of have to get close for the lid to be attracted to it. That one came pretty quick. And then let's play with the ball a little here. So the ball, you can see that, yeah, you don't even have to touch the objects to get them. Let's see, so this keyring seems to interact before you even look at it. You can see I'm making it move when I move it around. So that's like, and the screw even, you can get the screw to roll towards the magnet. Let's see. The force between the magnet and the metal object starts interacting before they even come in contact. And then I also want to show you with these little ones, if you break them apart, they have to come together a certain way because one side is going to attract. It's like a plus and negative. So one side's going to attract and the other side will not. So I'm going to put this on here. You can see, and then kind of show with the other one. See how it kind of flipped over? So that side doesn't attract. Let's do this. Break it apart. So these come together like they're pulling together pretty easy. If I flip one side around, I'm going to feel like a pushback. They're not going to come together. They're not being sucked together. I'm actually feeling some sort of barrier. But then when you flip it back, they come together. And you can fiddle with different magnets. We're going to have different magnets for you to test and different objects to show that you don't have to come in contact with them in order for the interaction to happen. And that is our activity on magnets.